However, there is a propositional surface where this is not a geometric impossibility.
Manifold.
Why have you just shouted manifold?
Because that's the surface that you're going to do it on. Non-geometric.
Therefore, if he's on the surface and it's rotating 360 degrees, he will have to look 360 degrees throughout the entire day to see the position of the sun change.
Yes, he turns around as though he is the center point. The rotation he makes means that he cannot be looking south all of the time when he's looking at the sun, which is what you claimed.
No, I didn't. I just told you that during the summer that's what he sees. Now during the winter, when the sun comes up and comes down,
not there.
No, right. But during the it depends where he is in the actually it depends. If he's on the Arctic Circle, he'll see the sun just tuck over the horizon, come over the horizon at certain times of year, and he will always look south to see that phenomena.
That's when the sun's going anti-clockwise, making anti-clockwise circles, isn't it?
No, the sun always goes in the same direction with respect to north for him, always in the northern hemisphere.
Not for him. Like when Jaren went to go and watch the anti-clockwise sun circles.
Yeah, that's because.
Point,
but right? this comes back to the point I was trying to make to you earlier on. Okay, right. Your friend, like in the spring, who gets a tiny portion of the sun come up and come down. Yeah, at noon he's looking south. Jaren is looking north to observe the sun at the same time.
He's watching the sun go around him also.
Yeah, I know, but because he's looking in the opposite direction, left and right are reverse for him, and so are clockwise and anti-clockwise in that respect.
And for Jaren, seeing the sun circle around him at another point where he thought he would be on the circumference of the sun circle, it did his head in. He couldn't work it out.
Well, he didn't think he'd be on the circumference of the sun circle at all. He's not on the tropics. The tropics is where the circumference of the sun is the limits. He thought where he was, the sun, if the sun was in the sky all the time, it'd at least be not in the northern area to him. He didn't see, there was no way for him to perceive the sun going behind him and being in the southerly direction.
Can we assume then it was a latitude circle problem that Jaren had rather than a sun circle problem? Right? Because he assumed that the latitude circles were expanding concentric circles about the north point.
No, he was making, in that proposition,
he was unaware that there was another point with latitude circles.
No, what he was doing is he was still assuming the sun was traveling latitudinally. He was still thinking it was going around a tropic at that point. Yeah. But what he assumed is that the nature of the shape of the Earth wasn't. He would, when he looked behind him, he wouldn't see it over the curve from the other side.
Yeah.
That's why it all fell apart for him.
Yeah, he couldn't explain it, right? He realized it was impossible to explain.
On a flat surface, without at least orchestrating,
possible to explain. Yes,
it's impossible to explain on a flat surface.
Exactly. Listen to me again. Impossible to explain.
I know, on a flat surface, unless you go on to invoke some other mechanism whereby the sun isn't a single light source where the rays don't come to you directly. However, there is a propositional surface where this is not a geometric impossibility.
Manifold.
Why have you just shouted manifold?
Because that's the surface that you're going to do it on. Non-geometric.
Well, a sphere is geometric, and the proposition fits a sphere.
It's not a sphere.
Well, you can assert it's not a sphere, but listen to what I'm saying. The proposition of a spherical surface.
It's not a sphere.
Bev, the proposition of it being a spheroid and that observation don't mismatch.
What? You sure?
Yeah.
I think you'll find that the new model is non-geometric.
What does that mean? What do you mean non-geometric? You think the Earth's non-geometric?
No, the globe is non-geometric.
It's a spheroid. It's a spheroid.
All right. That's a nice claim. Of course you can support it.
It's been mapped as such. Its overall topology is spheroidal. It has irregularities across its entire surface and a slight Again, you've got to let people finish what they're saying, Bev. You really have. This is 2025 and you're grown up.
Yeah.
The overall topology of the Earth has been measured to be a spheroid through geodesy. It has localized perturbations from that geometry, and it has an overall distortion between the poles and a couple of other distortions on the surface.
That is you making the claim, though, right?
Well, no, that's not me making that claim. That's what geodesy tells us.
You were the one that just voiced it, then.
No, I'm telling you what other people about the claim others make.
Oh, you're telling you what other people have said.
Yeah. People who've
You're
measured it.
telling me what other people have said.
People who've measured it. Yeah.
What have they measured? The angle?
They've measured the geoid and they've measured the entire surface, and they know where everything is on the surface with respect to each other, everything else.
Did Nathan Oakley tell you that? Because he's measured it flat by measuring an angle.
No, but why would I listen to Nathan? I don't listen.
Method?
Why would no? Nathan Oakley's not measured anything.
Okay, well, what's the method that was used in order to measure it? Not flat, I take it, right?
They've mapped out, they've surveyed everything on an intercontinental range, and everything only marries together in one context.
Again, nice claim. What was the method they used?
Again, I'll say it to you again. They've surveyed the entire surface. Every country's been surveyed now. Pretty much every country.
Yeah, I have experience in land surveying. I understand.
Okay. Yeah. Okay. So you understand that they've done ordnance for all of Europe, and most of the modern world has gone under ordnance. And the only way you can marry up all the distances between all the ranges of things is on a non-flat surface.
A non-geometric surface, right?
No. A curve is geometric, whether you like it or not.
Is it?
Well, yeah.
Give us a definition. there. The geometric.
So when I pick, well, I'll ask you a counter question. When I pick up any book on geometry,
your definition, your geometric definition of a curve, please.
No, I'm not going to do this to you. What I'm going to ask you, and you're going to listen.
Geometric. So
yeah, let me explain to you why I said that. Yeah, are you ready for me to explanation, or are you going to interrupt me again? Do you want an explanation?
Your geometric definition of the curve.
So right, let me answer it this way. Every single book I pick up on geometry has got curves in it. Now, just knowing that, I don't need you to tell me that curves aren't geometric or considered geometrical. That's a waste of time. I don't need to crawl through definitions with this and playing this silly game with you. Every book on geometry,
because every geometric book I've ever read doesn't have a definition of a curve.
Well, what do you mean?
You just said it's geometric, so please.
Why don't you think this? Why don't you've never found a curve definition?
Go on, give us yours off the top of your head.
Well, any line which isn't any line vector that isn't straight is a curve, isn't it?
What if you put like a 90-degree angle in it? Is that curve?
Do you think
that's not a line? That's not a line. That's two lines. There's two lines being it. Pardon? Sorry, Bev. I thought
the definition somewhere, or is that defined as straight? Is straight defined?
Okay. All right. So
Bev, not that.
Bev. So here we are. So a line or outline which gradually deviates from being a straight line. Okay. Now you're saying there's no definition of a straight line.
No, I'm saying there is a definition of a straight line.
Okay, and this definition here says that anything. Yeah, I know, and this is telling you that any line, any continuous line vector which deviates from being straight is considered a curve. Now, what's the problem with that?
They're not that then, right?
Well, yeah, in the same way as I can define cold with respect to hot, can't I? You buffoon.
So anything that isn't straight can be defined as a curve.
Any continuous line vector, yeah.
That's good to know.
Now that we've found a definition, and we all know that curves are in every single book on geometry, where are you going to go with this nonsense next, Bev?
Book on geometry, but I mean,
go on and show me a book on.
Just made a case.
Go on and show me a book on geometry which doesn't got curves in it. Go on, Bev. Off you go. Euclid. What? Euclid's not a book.
You sure?
Go on and show me the book called Euclid.
Elements of Geometry.
That's the title of the book. When you said Euclid, that's not the answer, is it?
Yeah, Euclid's. Like, how many other books do you know that he did?
Okay, let's have a look. Euclid. I'm just going to have a look because I've not read Euclid's Elements of Geometry
myself. Read it? Oh,
I've no. Let's have a look what's in it. Okay, so it's literally got circles on the front cover, you dopey bastard. Euclid's Elements. Let's have a look what it's got in it. What is he talking that book about?
Are you saying a circle's a curve? Or a circle's a circle?
Oh dear, Bev. Oh dearie me. That's shocking.
What?
That you asked that question.
Well, I'm asking again. Is a circle or is a circle a curve?
A circle is a form of curved line, isn't it?
Circle's a circle. It's a geometric figure.
Okay, so book three of the Euclid talks about chords, tangent circles, circles to circles, described angles, amongst other things. Yep. Okay. So let's pretend. Can we stop pretending now that Euclid doesn't talk about curves?
So now, can we go back to the east and west? Is that
before you do that, can you concede that Euclid's books do talk about curves?
No, let me just check.
Okay, go on, off you go. Talks about spheres, talks about cones.
A circle is a plane figure contained by one line, which is called the circumference, and such that all straight lines drawn from a certain point within the figure to the circumference are equal to one another. Yeah, it doesn't mention curves, mate.
Okay, that's it. That's all of Euclid's book. There's no mention of curve in the entire book. That's what you're saying?
The circle, yeah. Where would the curve be brought in? It's in the definitions. Do you understand what Euclid is and, the form of the axiomatic system? He wouldn't bring curves in if it wasn't brought in a definition.
Are you talking about Euclid? Which book are you talking about? Euclid's Elements? Which is the book you read?
Yeah, the Foundations of Geometry, Mathematics. Yes.
So Euclid's Foundations of Geometry. Let's have a look.
Good afternoon, gents. Well, whilst we're at it, Bev,
Good afternoon.
can you make a circle with a straight line?
What do you mean, make it?
Radius.
Yeah, can you make a circle with a straight line?
It is the radius that makes the circle, yes. All points.
It's the radius that makes a
equal
circle.
Distance, yes. That's the
Yeah,
point.
but you need a circumference to contain the
So
shape.
the circumference is all of the points of an equal distance from the other point.
Okay, let's take a circle. Let's take a circle and just take a slice. You cut the line. What do you have? A curved line, I guess.
Chord.
Yep, you do. You have a chord.
Chord and a segment.
Okay, but is that curved or is that a straight line? Then?
Well, the segment is curved and the chord is straight.
Yep, the chord is straight. That's true, but the segment is curved.
Curved,
yeah. Segment is the portion of the circumference that's been cut off by the chord.
A circle is a continuously curving line, which means that any part of it, any small subsection of that line is also curved at any resolution.
The circumference is just a series of points of an equal distance from another point.
Sure.
So that thing that you're calling a curve is just a series of points. And if you go back to the earlier definitions, a point is that of which has no parts.
Yeah, but all lines are conceptualized from
all lines.
Mathematical. I wouldn't even attempt it, really. It's not worth arguing about geometry at all, is it?
All lines are
a series of proofs.
Go on, then, Bev. Keep going. All curves and all straight lines and all lines are conceptualized as an infinite set of points cohering to one particular metric.
Yeah, I mean, you could technically, mathematically say a straight line is a curve.
Yeah. Well, excuse me.
Have you never heard mathematicians say that?
Yeah, but they don't. It's not a useful definition.
Well, it's a mathematical definition.
But it's not useful. It's saying that a straight line effectively is the circumference of a circle of infinite radius, but that's not in any practical sense useful.
Is there any mathematical proof for a straight line being curved?
The question is,
no proof associated with it.
If you've generated east-west circles, right, which obviously, like you've just said, they're not straight. Conceptually, how do you go to the equator and make the equator a straight line from east to west? Does that not cause problems with your conception of? Well, if the equator, right, is a measured flat latitude, as we just measured earlier, of 6,210 miles, then how does the sun go above your head in a straight line?
Measured. What does a measured flat latitude mean? What does that mean? Are you talking to me?
Well, just earlier, that's how we generated a circumference or a radius of the measured flat Earth.
The equator is a great circle, isn't it? It's the equatorial. It's the bisect of the equatorial plane.
Is that all right, guys? You all right? We measured it earlier as a circle. So if you want to say it's great, I suppose that's good. Is everybody all right? The flat earthers, they're all right. Because what I'm saying earlier, right? What we did, Nathan Oakley measures the Earth flat, and he didn't
measure. Nathan Oakley's measured nothing. Don't pretend he has.
I know he hasn't, right? But I mean, in his head, somebody's told him that if you measure an angle to a light in the sky, you measure the Earth flat.
Yeah, but in his head, he's charismatic. Who cares what's in his head?
Okay, right. So this is what we were talking to Flatside and all of them about, right? If 1 degree for 69 miles is a measured flat, right? Taking this is an argument. This is how we do this. Then 90 of those 69 miles will take you to the measured flat equator, right? Are you with us?
No.
So start again.
I'm not native English.
A 1 degree change in angle to the light in the sky as Nathan Oakley measures the Earth flat, an elevation angle, but you measure a 1 degree change. Reportedly, if you measure that distance on a map, it will be 69 miles. Right now, if that measurement is a measured flat Earth measurement, then 90 of those should take you from the light in the sky at your zenith, even though we've just said, that's, we've got circles and all of that, but we'll grant them that 90 degrees is where the light is. Then 90 of those 1 degrees would be 90 times 69 series of them. And that would take you to a flat Earth measured equator where there was a zero. You couldn't measure an angle to the light in the sky, right? Because it'd have disappeared.
Well, that's what I mean. That's in an arse backwards way. You define the distance between the North Pole and the equator, haven't you? There.
That's what the flat Earth, the measured flat Earth equator would be, wouldn't it?
It'd be on either. That's what it would be.
If
it's cutting the equator. It's cutting a ball at the equator and folding it up.
No, but that's what we say. If the Earth is measured flat, then the very act of measuring those angles would measure the flat Earth equatorial radius.
It would,
So,
yes.
So if you take a
would.
ball.
Okay, thank you. That's what we're saying, right? Right?
Wait, the
Okay.
what? The what would be what?
Yeah,
See,
90
now,
times
this is what we said.
69. Yeah,
How come no one has actually worked this out before?
Say that
Right,
last
because
part again.
Nathan Oakley's been saying that the Earth is measured flat by measuring these angles. You can't just be coming to this conclusion because we've been banned from talking to Nathan Oakley.
Well, that's not his actual argument. His actual argument is the tools that you're using to measure the Earth reference a flat plane.
Okay, so
So
if that
therefore,
flat plane was
everything is in
measured with
relation
those
to a
angles,
flat plane.
you would have a radius value of 6,210 miles.
Why?
Which means the measured flat Earth equator has a circumference of
So whatever-
39,000 miles.
Whatever the radius is for the sphere would match for the flat. That's just
That's
the
what
reality.
Flat Earth
No,
said. It
that's
doesn't.
not
It
true.
can't. How
Yes,
could that
It
work?
absolutely is true. Because what you do is you take a ball, right?
Is-
You put
is
a pin
the-
in it.
is
Can I
the road
explain to you
radius
why it's the same?
210 miles. It's
I
not
don't
the
need to do this
same.
with numbers. I just need to do this with like a
It's
visual
not
for you, right?
the same.
So if you take a ball,
Oh,
right,
God.
and you put a pin right through
Like
the
listening
middle
to
of it,
Flatside over again.
right, and then you cut that ball at the halfway point, and then you fold it up, what do you get? What do you get for
You get a
distance?
ball. You get a ball.
You've got like
No, you
you've
fold it
got
up to
half
flat.
of a ball.
Okay. And would those measurements match?
No.
Yeah, they would. It's a
What
radius
do you
point.
think? Where does
The
that
radius
happen
to
in
the center
reality?
of a
Like,
ball.
when
my
we were
goodness.
measuring angles and
Yeah, but you're
distances.
saying it can't happen, and then you're assigning a new radius, and I'm showing you how it can happen.
No, I'm
And you're
not
saying,
saying
no,
it
it can't happen.
happen. Listen, stop getting triggered.
I'm not
We're
getting
just
triggered. You're
saying-
just being difficult for no reason.
No, we're just saying that is the measured flat Earth.
No, you're creating a
saying
new
no.
radius. Yes, you're creating a new radius by ignoring what I'm saying. If you have a radius to a ball, you can transfer that radius to a flat very easily. And I
No.
just explained to you how to do it.
It's not
But he's saying-
6,210 though. Like why?
Yeah, what he's saying is because it's 6,210 miles. If you're the globe gets away with it because that's a curved surface. So for their radius, it works out still to the 24,000 being the
No,
circumference.
it's not a curved
But-
All the
surface.
measurements,
But
all
I
the
know I
measurements,
understand that, but I was just trying to explain it.
no,
Just
all the
because
measurements are irrelevant, is what I'm trying to explain.
Straight
Because you have a
lines.
radius. You have a radius from a center point on a ball, right? So if you look at it, say you just take north, right? And then you draw that radius is from the center
Why
to
do you
the
have a
north.
center point on the ball? Where do you get that from?
Holy fuck. Are you serious, dude? You
Yeah,
just
I'm
don't want me to
absolutely
explain it. You
serious.
just don't
Where
want me to
did you
explain it. You're
get
gonna
it
give like
from?
stupid ass questions like how do you
Where
build a
did
center
you
point?
get it from?
Oh my god. So you want a new argument. You just want to ignore
No, I just want to
the
know where
current
you got
argument?
it from.
You want to go to a
Where-
completely different argument.
Where did you get it from?
Bev, you're going to have to let him finish his point without
Yeah, he's just-
injecting another one.
Picked up a center point.
No, like just think of a compass. Like take a compass, right? And set it to the radius of what it would be on the sphere, right? Then swing that compass up. Swing it up. You're gonna get the same exact distance. Right? So if you take your north, that's you're gonna create a new reference point because you establish center to north on your ball, right? So you have that radius distance and you just set your compass that way. All right. Now take that compass and swing it 90 degrees. Right? Now you have a flat line. Right? You have that curved line, that pizza pie shape. Now bring a line from that point to your center point, and now you have a flat. It's the same fucking distance.
It's not though, is it? I mean, the straight line distance between the North Pole on the AE map and the equator means that the
Would
equator is
be the
different.
same thing as what I just
Okay.
explained to you.
No, it's not.
It's a center point.
Now you're ignoring what people are saying halfway through for some reason, just like Bev was. I don't know why.
You're not addressing what I said.
I am addressing what you said. I am addressing what you said. If the Earth's flat and you know the distance between the North Pole and the equator, that gives you a value of r for that distance, yeah, which is what Bev said. If you multiply that by 2 pi, that gives you the length of the equator according to what it is on the AE map. Now, on the Earth, the distance r to the equator is not from the North Pole; it's from the axis it's going through the core. So it's different. It's a different value.
It's based on center. It's based on the north.
Yeah, but the distance on the globe, the 69 nautical miles times 90 is not a straight line. It's a bend. Therefore, it's a smaller distance. Okay, fine.
That is
carry
the
on.
reality
No,
measurement,
because
right?
every reference
That's
point
69
comes from
miles
the
and that
north.
1 degree. They're the things we do in
No,
reality.
no.
It all
The
comes
equator, the equator is on a sphere. The equator isn't measured from the North Pole. It's measured from the line that goes between the poles, the axes. It's different.
Okay, so how do you find that location? What's it in reference to? Our only reference point is north, magnetic north.
No, not on a sphere. It isn't. That's not our only reference on a sphere. There's no
northern hemisphere.
In
whole
reality, the
northern
equator
hemisphere.
is where you cannot see Polaris, right? It disappears.
No, the whole northern hemisphere has
Is that right?
magnetic north
Is that,
and Polaris. Those are your reference points.
is that a correct statement?
How many miles is the equator in reality?
I don't know.
I have no fucking clue.
How would anyone even go about measuring
Is the
that?
69
Well, that's a
miles
good question.
1 degree a real thing? Can we confirm
Oh.
that?
Yes, it is a real thing.
Right,
I don't think
that's
I don't
something
think
that we
it's
can confirm.
no. I don't
Yes,
think that's a real thing at like 0 to
You could do
15.
that, right?
So what's celestial navigation then? Is that not a real thing?
No, it works in specific scenarios, but from 0 to 15 and 75 to 90, I've seen it not really work out exactly
But
one
can we
per
agree?
What do you mean? What do you
Can we
mean from
agree
75
that
to 90? Who
the
told you
claim is
that?
69 miles. So you
Oh,
could travel 69 miles and measure 2 angles and confirm this for yourself.
yeah.
You could do that, right?
Yes.
Right. Okay. Now, the person that said it wasn't that, can you agree that you could do this and check? And then you would be able to come back and say it does or it doesn't happen. Right. And until you've said that and done that, then it would be safer to say that it's possible that this could be a real thing.
Okay,
We
yeah,
agree on that.
from 0 all the way to 90, in order to verify it, you would actually have to walk from 0 to 90, is what you're saying. But is it a
1
possibility?
degree. You could check the difference of 1 degree has a measurement of 69 miles on a map. You could place 2 points. You could go to one of them, measure the angle, then drive to go to the other point, 69 miles away, and measure an angle. And there would be a 1 degree difference in those angles.
Yeah, I would agree with that, but I don't know if that's going to be consistent across the board around the whole entire Earth.
Well, if everybody could do that and confirm it for themselves, wherever they were, then it would seem to confirm that it happens everywhere, right?
No, not at all. 90% of people don't live like it's just not. No, we have a lot of water here.
Yeah, I know. Obviously, you can't do it on water because you can't measure the 69 miles on a map. You'd have to do it on the land. But everybody who has 69 miles north-south could actually do this to check, couldn't they?
Okay, yeah, and I understand your point with the 6,200 mile radius making the circumference extremely large. And so are you saying like, why hasn't anyone brought that up to Nathan?
I'm just saying that's what happens in reality, isn't it?
I don't know. I don't know if that.
But that's the point. Why has nobody done this? Nathan Oakley's got a Flat Earth book coming out, right? A reference book. But why are we just talking about this now? I mean, it's a pretty simple calculation to do, isn't it?
Yeah,
if
I tried to
Earth's
explain
measured
it.
flat by measuring these angles to a light in the sky, and if 69 miles is the distance between these angles, then you can come up with an angle where the equator disappears.
Yeah, this is not the first time this has been brought up, for sure. There's been many people that have said the North Pole to the equator radius causes, and because on a globe versus flat, causes a different equator circumference. I've heard that many times before. So yeah, because on a sphere, that line would be like, it's like on a flat circle, it can't be any more than, I can't remember if it was 2 pi, or on a sphere, it can't be any more than 2 pi or something like that because of the geometry, right, Bev?
Geometry.
Or because of, how a circle works?
Yeah,
Well, that's
well,
why
the
everything
circles are
below the
Euclidean
equator
geometry,
falls
right?
apart. It's literally the
Right.
reason why everything below this the equator falls apart. The
There's
southern
certain
hemisphere
rules within
doesn't work,
geometry, right, that can be applied. And if
but everything
you
above the
can't
equator
apply
works.
those rules, right, and if it doesn't follow those rules of geometry, you've got to call it non-geometric, right? You can't call it geometric and have the rules of geometry not
Call it
apply to
incomplete.
it, right?
Call it incomplete.
Call it non-geometric. That's what the new
Incomplete.
model is. Welcome
No,
to the
incomplete. Bev.
real
Incomplete.
globe, where all of the proofs of reality combine to show you exactly what reality is. The real globe. By the way, it's non-geometric. You'll struggle to explain it, particularly with because your obviously understanding is like geometry. Your spatial reasoning is linked to Euclidean form, line, understanding, axioms, and all of that sort of stuff.
Yeah, but I don't even think we have flat in reality with your paradigm. So, like, what's what I
That's
mean?
a visual surface condition.
No, you don't have flat. You don't have flat. Yeah, we already established this like a few days ago.
So,
You
yeah,
don't
it's
even know what
a
flat
visual
is in
surface
reality.
condition. Yes.
So it's like, what's the point of saying non-geometrical? You can't establish even a concept in reality. Like
Yeah,
you can't even
define
establish what
flat as being
is.
a visual surface condition, like I
Okay,
did the other day.
in
No
relation,
problem.
is it ever going to be in relation to something, or is it just perfectly smooth?
No, smooth is smooth. Flat is a visual surface
Okay,
condition.
is it
Smooth
flat, or
touch
is it in relation to something that's
related.
considered flat?
It's a visual surface condition.
Okay, so tell me something that's flat.
This whiteboard here.
Okay, so what happens when you zoom in? Is it still flat?
No, I'm not zooming in.
Yeah, what happens when you do? Is it still flat? Because it's in reality. We can zoom in reality.
Yeah, the
Yeah,
whiteboard.
what happens to the
is
surface?
flat, yeah,
So it stays flat. Okay, well, there we go. We have your relation. All right.
it's quite smooth as well.
All right,
Flat
well, we know.
and
So
smooth.
therefore, we can say, in relation to the size of the Earth, the surface is flat. Just
You can say
using
that if
that
you want.
logic. Yeah, well, I'm using your logic. Because you
I don't
said,
know.
yeah, of course you do. You just said the whiteboard's flat. I said, well, when we zoom in, you said, well, yeah, it's flat. Okay,
Hold on,
okay, well,
if you think
Already.
about what he's saying though, like with the equator thing, you do see that problem, right? Like, what do you think the distance from the North Pole to the equator is? Do you think it's 6,200 miles?
I think it's going to match whatever the globe is. Because
Okay, so
everything's built on 2 reference points, right?
yeah,
Well,
yeah,
actually
but
one, right? It's not like we're building from the center of the Earth. That's not happening.
Do you have
We're just
latitude and
taking-
east and west as circles?
We're just taking
Somebody-
the North as a
Somebody
reference
told
point,
you an
and we're
equal
building off of
circle of
that.
equal elevation. Somebody told
I
Hold
was
you.
on,
trying to
Bev.
get to him, Bev. Like,
Yeah,
shit.
hold on. I
No,
just want to
it's
ask
the
him this.
circle that's the problem.
But if it is a 6,200 miles from the North Pole to the equator, right? And that's in every direction, right? From the North Pole to the equator is 6,200 miles. Then now you have your radius of 6,200 miles. Now to get the circumference of that circle, right? You would just take the diameter and times it by pi. So 6,200 times 2 times pi. And you're going to get a number way bigger than 24,901. You get that?
The circumference of the circle. Yeah. And what would
Yeah.
it be on the ball?
It would be different on a ball
Would
because
it be like 24, 25?
it's 24,901 on the ball, right? On their ball, because that's a curved surface going from the north to the south or to the equator. And I know, Bev, that's not exactly how you want to describe it, but that's how I'm describing it. And
Yeah, so it's about
on a
25.
flat, yeah, and on a flat Earth, it would be 38,998 miles. So it's like a 13,000 mile difference.
Yeah. You're just describing the false dichotomy there, right?
Yeah, exactly.
You could do this, right? So if you take a penny, right, and you put a little plus sign on it, right? Dead center, you have the lines intersect. Okay, you got a plus sign. You put one of the lines, label it as an N, right? And then 180 degrees on that line, you just put an S, right? And then on the one perpendicular to that, on the right side, you put an E, just like how a compass would work, right? You put that in the middle of your table, and then you do an angle measurement from that, right? Can you extend south?
Could you put north at the center?
No, I'm saying, can
Or
you
putting the
extend
penny at the
south?
center?
Yeah, you put the penny in the center.
So the penny's the monad. But
Yeah, I'm
there's
just
still
saying it's your
cardinal
reference point.
directions.
I'm saying it's your
Right.
reference point. Can you build
Yeah.
off of that reference point?
Cardinal directions.
Can you build
All
off that?
stand.
Can you
North,
build?
south, east, and west, right? All perpendicular from that
Yeah.
penny.
Yeah, can you build off that reference point?
Of course you can.
Okay. Now delete all the lines on it because we established a reference point, right? And we're just going to put a big N on it.
Oh, right. Now you put north at the center. Neat trick.
That's exactly what we do.
Well, yeah, but you just add east and west as the cardinal directions. And
Yeah, but it's
changed it
irrelevant.
once
That's
you
what I'm
put
telling you.
north in the
It's
centre.
arbitrary. East, west, and
me.
south are arbitrary. Our reference point is north.
No, you
So
put
I
north
just
at the
told you.
centre.
I just told you. Can you build off of that penny? You said yes. I said okay. Then delete all the lines and put an N on it and call it north. Can you build off that penny?
No.
Oh, now you can't. You can only build. See, now you're
No,
just
because
being
you put north at
disingenuous.
the centre. I can't do
Now
that.
you're
I
just
told
being
you.
disingenuous. But I already
Said
told
that
you what.
earlier.
I already told you what
Said-
south is. I already told you
Right,
what east
listen,
is.
listen
I
to
already
me
told you
again.
what west was.
Please,
You established
listen to
that. You
me.
understood it. You said you could
I
build
said
off it.
I
But now when I
can't put north at the centre.
you just
I
did.
don't have that ability. No, you put the penny at the centre.
We just talked about it. Yeah, the penny, and then we're going to call the penny north.
Yeah, but that doesn't put north at the centre in my mind. I can't do
This is
that.
just
Listen,
this is
listen.
simply a
I
hypothetical.
cannot do that.
It's a simple hypothetical. If you don't want to play along, just say you don't want to play along.
Say I can't do it. Anybody else open to putting north at the centre? I mean,
Well,
you got there.
you got there, and then you walked back.
A compass, and then
You got
imagine
there, right?
what's happened to all of the other cardinal directions if you
No,
were to
when I
give
gave you
north
all-
a specific
I gave you
monadic
all
position.
4 cardinal directions. I put them on a penny, and then I put it on the table in the middle of the table, and you got there. I said, "Can you build off that?" You said yes, and then I said, "Okay, delete all of them and just put the north there." And you're like, "Oh, I see what he's doing. I'm going to disengage."
No, that's not what I was doing because you just wiped
That's exactly what you
everything that
did.
we just agreed on. So wipe it.
Yeah, because we established how
I
cardinal
can't
directions
get
work.
rid of east, west, and south. And
Yeah,
give
we
north
just
a
established.
monadic position. I cannot
We
do
just
that.
established how the cardinal directions work in relation to each other, right?
Don't think that's what we did.
Yeah, we did. I told you how I put the lines.
I know how
The
you
north,
do
the
it.
south, the N, the S, the E, the W. I established how, made the rules for establishing those directions, right? Those letters. I explained it to you. Why I was doing what I was doing. And then we put the penny on the table, and you were following with me, right? But then the second I removed all the cardinal directions and I assigned a single cardinal direction as a reference point, you disengaged immediately because you knew where it was going.
Yeah, because I have them as cardinal directions, and I
Yes,
can't
'cause
put
we
any of them at the
established-
centre.
We established how the cardinal directions are assigned. And then I said, okay, well, we established that phase, right? And now we're just going to take a single cardinal direction and call it a reference point. Can you build off of that reference point? And you said, oh, I'm done.
It's been interesting.